Welcome to The Explainer. Today, we're going to permanently untangle the physics of movement. We hear words like speed and velocity tossed around all the time in everyday conversation, often used totally interchangeably. Whether you're driving a car, watching a sports broadcast, or just going for a quick jog, you've probably used both words yourself. But in the world of physics, they tell two completely different stories. My goal today is to map out these concepts so clearly that you'll never ever confuse them again. We're going to build this understanding right from the ground up.
All right, let's just dive right in with a bit of a mind bender. Imagine you just traveled exactly 100 meters. You put in the physical effort, your heart is pumping, you traveled a very real path, but you ended up exactly at the same place you started. Did you really move? In a fundamental physical sense, what does movement actually mean if your starting point and your ending point are completely identical? Hold on to that paradox for me, because it's the exact riddle we're going to solve today, and the answer fundamentally changes how we view motion.
Section 1. Establishing the baseline. What exactly is speed?
So, to crack this paradox, we've got to establish our baseline rule. Speed is, simply put, a measure of how fast an object is moving. That's literally it. There are no hidden layers or complex caveats here. It's calculated purely by taking the distance you traveled and dividing it by the time it took you to get there. It depends entirely and exclusively on those two specific factors, your total distance and your total time.
Let's see how that plays out in the real world. Say you travel a distance of 100 meters, and it takes you exactly 10 seconds to pull it off. You just divide that 100 meters by 10 seconds, and boom, you get a speed of 10 meters per second. It's a wonderfully simple, intuitive calculation that we rely on every single day. But there is a very specific catch to how speed views the world.
Now, what's really wild here is understanding what speed completely ignores. Speed absolutely does not care about direction. It is totally blind to it. Whether you're moving on a wide curve, running in a perfect circle, or sprinting in some chaotic zigzag pattern across an open field, speed only counts the total distance your feet actually covered. It's exactly like a pedometer tracking your daily steps. It eagerly counts every single one, constantly adding to your total, completely regardless of which way you're facing or where you ultimately end up.
Which brings us to Section 2, the twist, adding direction to the mix.
And here is the plot twist of our explainer. We just established that speed is completely unaware of direction. Well, velocity is a whole different ballgame. Velocity takes everything we just learned about speed, all that raw momentum, and simply slaps a directional arrow on it. By definition, velocity is speed in a specific direction. It's not just about how fast you're moving, it's about where that movement is purposefully taking you.
So the crucial distinction really comes down to intent. Think of it this way. Speed only ever asks one single question: how fast are you going? But velocity asks, how fast are you going and which way are you heading? You literally cannot fully describe velocity without pointing a compass. It is speed, but with an absolute sense of direction.
Moving on to Section 3, the core conflict, distance versus displacement.
This right here perfectly illustrates the absolute crux of why speed and velocity are so fundamentally different. It all comes down to what they actually measure. Speed relies on distance, and distance is that exhausting total path you covered, every single zig, every zag, every little detour you took along the way. But velocity? Velocity uses displacement. Displacement is strictly the shortest, straightest line from where you started to where you ended up. It completely ignores the winding path. It couldn't care less about the scenic route. It just draws a perfect straight line from point A to point B as the crow flies.
Section 4, the resolution, the zero velocity phenomenon.
Okay, let's tie this all back to our opening paradox. Imagine running a full circle around a track. Step 1. You run the circle and return right back to your starting block. Step 2, your total distance is definitely not zero, right? You just ran a long, hard way. But look closely at Step 3. Because you ended up exactly where you started, the straight line distance from your start to your end, your displacement is exactly zero. And because velocity relies entirely on displacement, Step 4, your velocity plummets to absolute zero.
Think about the hilarious tragedy of this physics rule for a second. You could be sweating, completely out of breath, and boasting a massive speed because you put in the physical work and covered all that distance. Your speed is absolutely not zero. But mathematically speaking, because you didn't actually displace yourself from your original starting point, your velocity is zero. To velocity, it's like you never even got off the couch. All that effort, zero velocity.
And finally, Section 5, final summary, tying it all together.
Let's lock this into memory. Notice how the formulas differ fundamentally based on what they're actually measuring. Speed relies on raw distance divided by time. It has absolutely no direction, it just wants to know how much ground you covered. Velocity, on the other hand, demands displacement. That straight, unwavering line from start to finish, divided by time. And because of that, it always has a specific direction.
So there you have it. We've solved the paradox. You can move 100 meters, have plenty of speed, burn a ton of calories, but still mathematically have zero velocity if you end up exactly back where you started. So I want to leave you with this final thought. Next time you run a grueling circle through your neighborhood and end up right back at your front door, ask yourself, was it worth the zero velocity? Thanks for joining me for this explainer. I really hope this clears up the physics of movement for you.